Hello, Stings. This will be part 2 of our characteristics of quadratic functions. We had started out with this page, done some cutting, and we ended up with 2 pages. Part 1 was the page with the large graph on it, and part 2 is going to focus on the key features of quadratic functions. Now, I've already pre-folded this to some degree here. Notice that we do have some problems with words cutting off, and we'll come to that. And then right here, we're going to have an issue with cutting, and we're going to have to be a little bit careful about that. But if you'll notice on the inside, you pretty much cut on these except for this tab. That's where those words are going to get a little tricky. So what I did on that was I went ahead and opened it up, and I cut these here. But on this one, I went this direction and got really close to that word solutions to cut that one. And then I have all of those cut, and then we can cover things up this way. So here we have domain. We're going to start with the domain. The domain is basically the set of x values of the function. And what that ends up being for parabolas, which are what we call the graphs of quadratic functions, is all real numbers. I'm going to use the symbol for numbers and also the symbol for all real numbers. So there's our set of x values. The next key feature we come to is range. Now range is the function's set of y values, and we have a couple of options. If our parabola looks similar to this and opens up, let's say here's its vertex, then the range is going to be y is going to be greater than or equal to the y value of the vertex. Okay, so the y value of the vertex is the number that goes here, and y is going to be bigger than that if you have a parabola that opens up. If you have a parabola that opens down, then y is going to be less than or equal to the y value of the vertex. So that's domain and range. Next we come to zeros, x-intercepts, also called solutions. These are the values where the parabola touches the x-axis. And so as an example, here we have our x and y axis. And let's draw a parabola here. And these points right here, these are our zeros, also known as our solutions. We call them zeros because the value of y is 0 here, and it's where it touches the x-axis. That's why they call them x-intercepts. And solutions is just the other name that we use for that. Okay, then we have our y-intercept. So here, the y-intercept is the values where the parabola touches the y-axis. So we call them all kinds of things when they're x-intercepts, or when they're y-intercepts, it's just called y-intercept. And that looks like this. Here we have, let's get that tab out of the way just a little bit. Here we have a y-axis, and here we have an x-axis. And we're just going to draw a parabola, and where it crosses the y-axis, this is our y-intercept. Let's do y-int for the abbreviation. Next is our vertex. The vertex is the highest or lowest point of a parabola. So when a parabola opens down, its vertex is up here, and we call this a maximum or a max. And when a parabola opens up, its vertex is called the minimum or the min. And these are the vertexes, either the highest or the lowest value of the graph. An axis of symmetry. This is when we have I'll go ahead and draw in an X and a Y axis. And I'm going to offset my parabola here. Go ahead and use red for the actual axis of symmetry, but we'll go ahead and do here, here. We're going to call this our vertex. So the axis of symmetry is that vertical line that goes through the vertex. It cuts the graph in half. It's a vertical line that cuts the parabola in half, and it is always of the form x equals the x value of the vertex. Okay. So we have a vertex, which is a point that gives us a maximum or a minimum. The x value of the vertex tells us the equation for the axis of symmetry. Next, we have some transformations. And this will be the last part of this video. Okay, so we know that we have, let me get this tab out of the way. We know that we have y equals, let me pull this back in, ax squared plus bx plus c. So we know that we have that, and A tells us how the parabola changes horizontally. It either widens or narrows, and it's the direction that it opens up or down. And that's and then C tells us a shifting up and down, and where the y where the y-intercept is. So just dealing with A here, we're going to have A is greater than 0 means that it opens up. If A is less than 0, then it opens down. If A is greater than 1, it gets more narrow or narrower. And if A is between, oh, I need to erase that. If A is a fraction, which means it is between 0 and 1, that means it's a fraction, then we have, it gets more wide or wider. Whoa, I need a W there. More wide. Okay, then we have C. C changes the parabola vertically. So if C is greater than 0, it moves up. And if C is less than 0, it moves down. Okay, so these are some of the key features. Let me open that back up. So the function set of x values is all real numbers, and that's what we call our domain. The set of y values, which we can get from the vertex will tell us that it's either going to be greater than or equal to or less than or equal to the y value of the vertex. The values where the parabola touches the x-axis, these are our solutions called zeros, called x-intercepts. The values where the parabola touches the y-axis are our y-intercepts. Typically there's only one, should be only one. The highest or lowest point of a parabola is our minimum or our maximum, called the vertex. We have a vertical line that cuts the parabola in half. This we call our axis of symmetry. That would be right here. And then we have some transformations, and we will have another video where we go into this in more detail. But right now, if A is greater than 1, it opens up. If it's greater than 0, it opens up. If it's less than 0, it opens down. So if it's negative, it opens up. If it's positive, if it's negative, it opens down. If it's positive, it opens up. If A is a number larger than 1, Whether it opens up or down is inconsequential. It'll just make it really narrow. If A is a fraction, whether it be positive or negative, it's going to open wider. And then C is what's going to move our graph up or down the axis of symmetry. So if it's a positive number, it moves up. If it's negative, it moves down. And we'll get into that in more details in another video. So this has been part 2 of characteristics or key features of quadratic functions.